Prove and explain graphically the difference between the relations xn convolution delta of n minus n0 is equal to x of n minus n0. Now here this symbol we write here it indicates convolution. So we have to calculate convolution x of n and delta of n minus n0. Now according to definition of convolution, yn is equal to x of n to h of n. So summation k goes from minus infinity to infinity, x of k into n minus k. This is equation 1. Now consider or let h of n is equal to delta of n minus n0. Now assume two sequences as follows. We write here, now assume two sequences as follows. So it is x of n, first sequence is 1 1 1, and h of n is equal to delta of n minus n0, it is 0 of 1. So these are the two sequences. This is equation number 2. Also assume, we write here, also assume value of n0 is 1. So we cannot assume any arbitrary sequence for h of n, since hn is equal to delta of n minus n0, and it should be in the terms of delayed unit impulse. Now we draw the diagrams. Now we draw the product diagram for the product of xn and delta of n minus n0. First we draw x of n. So this is n, it is x of n, 1 1 2 1 1. Sorry, here the x of n we considered 1 1 1. So we draw the diagram for this sequence. First we write here step 1. Step 1 is sequence x of k and h of k can be written by directly replacing n by k. So we write x of k is equal to 1 1 1 and h of k is equal to delta of k minus n0. This sequence is 0 and 1. Now different samples, we write here different samples x of k and h of k can be written as x of minus k is equal to 1, x of 0 is 1, and x of 1 is 1. Similarly, h of 0 is 0 and h of 1 is 1. Now we have to plot for x of k and h of k. So we draw for x of k. This 1 1 1. This is k is minus 1 0 1 1 1 1. Next we have to draw for h of k. So this is h of k, this is k, it is 0 and 1. For 0 and for 0 it is 0 and for 1 it is 1. So these are the sequences for x of k and this is for h of k. Range of k is same as x of k. K varies from -1 to, we write here. Next step 2. Now the range of n we have to calculate. Range of n. So lower value of n y1 equal to x of l h of l, so it is -1 plus 0 1, and higher value of n goes to yh, it is xh plus hh to 1 plus 1, it is 2. So thus range of n is from -1 to 2, that is we have to calculate sequence yn from y of -1 to y of 2. So we write here range of k is same as x of k. Thus k varies from -1 to +1. Next is step 3. Now put step 3, put the value of k. Equation 1 can be written as y of n is equal to summation k goes from -1 to +1 x of k into h of n minus k. This is equation 3. Now to calculate yn, put the values of, right here, to calculate y of n, put the values of n from -1 to +2. Now calculation of y of -1. Calculation of y of -1. So put n is equal to -1 in equation 3. We can write y of -1 is equal to summation k goes from -1 to +1 x of k h of -1 minus k. This is equation number 4. Now here we have to write here h of -1 minus k is same as h of minus k minus 1 into h of minus k, and it is folded version of h of k and h of minus k minus 1, which indicates advance of h of minus k by sample 1 or by one sample. So the sequence for this we have to draw now. This is k and this is h of minus k. Now it is 1 and 0. So for 0, for it is minus 1. For 0 it is 0. For minus 1 it is 1. And next is it's advancing. So we draw here sequence for h of minus k minus 1. So it is, so for 0, minus 1 and minus 2. For 0 it is 0. For minus 1 it is 0. For minus 2 it is 1. Now we write here this figure is for sequence h of minus k minus 1. Now the multiplication of x of k we have to draw for multiplication of this x of k and h of minus k minus 1. Now we draw multiplication of x of k and h of minus k minus 1. So we draw here first x of k. This is k, this is x of k is 0, 1, 1, 1. This is 0, 1, minus 1 and minus 2. For 0 it is 1. For 1 it is 1. Here for minus 1 it is 1 and this is 0. And next is h of minus k. We already draw here k minus 1. Now multiplication of both these signals we get this is k and this is x of k multiplication of h of minus k minus 1. Now for 0, 1, it is minus 1 and minus 2. So for 0 here value is 0 and here it is 1. It is 0. For this it is 0. For minus 1, 0 into 1, 0. And for minus 2, 1 into 0, it is 0. So this graph is for, so here y of n is equal to y of minus 1, that is 0. So we write here y of minus 1 is obtained by adding all product terms. Therefore y of minus 1 is equal to 0. Next is calculation of y of 0. Calculation of y of 0. Now put n is equal to 0 in equation 3. So equation 3 becomes y of 0 is equal to summation k goes from minus 1 to plus 1 xk into h of minus k. So these are the diagrams for multiplication of x of k and h of minus k. This is a calculation of the y of 0, and these are the diagrams for x of k and h of minus k. multiplication of h of k and h of x of k and h of minus k. So here we have to find the value of y of 0. So y of 0 is obtained by adding all the product terms. So y of 0 is equal to 1. Next is calculation of y of 1. Now put n is equal to 1 in equation 3. So equation 3 becomes y1 is equal to summation k goes from -1 to 1 x of k h of 1 minus k, equation 6. Now we write here h of 1 minus k is same as h of minus k plus 1, and it indicates delay of h of minus k by one sample. It is obtained by shifting h of minus k towards right by one sample. So the sequence h of minus k plus 1 is shown in figure. So first we draw the product of x of k and h of minus k plus 1 we have to draw. First we draw h of minus k is 1 0. Next is delaying of this signal. This figure shows sequence h of minus k plus 1. So draw for x of k one 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 and next is h of minus k plus 1 it is 0 1 0. And multiplication of both these, so we get x of k into h of minus k plus 1. So it is 0 1 0. So here we have to find the value of y of k, y of 1. So this is y of 1 is equal to 0. So here we write, therefore y of 1 is equal to 1. This is the value of y of 1. Next is calculation of y of 2. Put n is equal to 2 in equation 3. So it becomes y of 2 is equal to summation now here h of 2 minus k is same as h of minus k plus 2, and it indicates or it shows delay of by 2 samples. So it is obtained by shifting h of minus k towards right by 2 samples. Now we have to draw the sequence for h of minus k plus 2. So first we draw for h of minus k. This is delaying. This is h of minus k plus 2. Now we draw for x of k. It is 1 1 1. Now multiplication with h of minus k plus 2 and answer of both answer of these two multiplications. h of x answer x of k multiplied by h of minus k plus to h of x of k into h of minus k plus 2. So we get 0 into 0 0, 1 into 1 is here, it is 1, and this is 0 into 0 is 0. So you will have to find the value of y of two. So y of 2 is equal to 0. It is 0 0 1. So we write here y of 2 is obtained by adding all product terms. So y of 2 is equal to 1. Now the output sequence yn. Right here the output sequence y of n is therefore y of n is equal to 0 Now we have to draw this sequence. So this is the sequence for y of n or output yn. Now the output yn can also be written as we write here. Now output yn can be written as yn is equal to 1 1 1. Now output yn is obtained by delaying x of k. We write here output yn is obtained by delaying x of k by one sample. Therefore yn is equal to x of k minus 1. But x of k is same as x of n. So yn is equal to x of n minus 1. Initially we assume n0 is equal to 1, so y of n is equal to x of n minus n0. So equation y hence the equation is proved. So we write here hence it is proved.